Hello everyone, in this video I will explain the current and next generation display technologies based on organic light emitting devices, especially for the development of low cost and flexible displays. A lot of scientific zest and engineering efforts have gone into the development of displays since 2 decades, and now we have many of those products available in the market, like this LG TV and Samsung Galaxy smartphones. In past few years, we have also seen many prototype products for full color and video rate flexible displays, both for large area display applications and for mobile device displays as well. Another expanding research area in this regard is see-through display for multiple applications in auto industry and for medical equipment. If we take a look at the challenges involved in making of active matrix display pixels, the most crucial part is integration of transistor circuits required to run each color pixel. This is commonly referred as transistor backplane and used in all of existing active matrix display technologies. This backplane consists of thin film transistor or TFTs to control individual pixel. For these backplane TFTs, the working horse, the active material, has been amorphous silicon. The amorphous silicon has played for a long time, especially for the LCD based displays, but the amorphous silicon has its limitations. For example, lower charge carrier mobilities, which is around 1 to 2 centimeter square per volt per second. This is fine for low resolution displays, where the high refreshing rate is not required, but for active matrix OLED displays, amorphous silicon is not enough, and it can be replaced with low temperature polysilicon technology, which is also known as LTPS. LTPS based TFTs have much higher charge carrier mobilities, which is around 100 to 200 centimeter square per volt per second. Unlike LCD based display, OLED display do not require any backlight, and they just use organic light emitting diodes, which are encapsulated with the cover glass to protect them from moisture and oxygen. Before going to the fundamentals of TFT engineering and materials for TFT, let's understand how the backplane looks like, which consists of scan lines and data lines. This pixel array basically allows to address any particular pixel using these scan and data lines. Each cell of this array consists of control circuitry, which consists of anywhere between 1 to 6 transistors and few of capacitors. This control circuitry takes input from data lines and scan lines and generate output signal in form of current for the OLED. Here is an important parameter for the display pixelation is called aperture ratio or fill factor, which refers to the ratio of light emitting area to the total area of each pixel cell. And now let's have a look at control circuitry of a typical 2 transistor 1 capacitor architecture to drive the OLED. If we turn on the scan line and we have a high voltage at data line, the charge is stored at storage capacitor, which in turn turns on the drive transistor and using the power line drives the OLED. The drive transistor need to be capable of supplying high enough current and maintain a stable current at high voltages and low voltages. But we can replace this lower part with just one multifunctional device, light emitting transistor. This makes the pixelation easier and low cost, removing additional fabrication steps. This also enables the use of flexible and stretchable materials for both control circuitry and light emission purposes. Light emitting transistors are multifunctional and new technology. They can be used in many applications besides next generation display technologies. These technologies include communication devices, a more sensitive optoelectronic sensor system, electrically pumped organic lasing. Thank you for watching this video.